This is Science Bubbie and
Science Asher.
And we are here with our safety equipment, our glasses.
Safety goggles.
Must always wear safety goggles, right?
Mm-hmm.
Right. We're going to make today a lava lamp or blobs in a bottle, whichever way you want to call it. We get together just like any other experiment. You have to have all the different things that you need for the experiment. It's like cooking. You have to have all the things. Whoop, there goes the lid. Okay. Science. Asher, let's put in some water. First thing we're going to do is just add plain old water. We're using a funnel because it makes it easier.
3/4 of a cup water.
3/4 of a cup water. There we go. There it goes in there. Now we're going to add food coloring. Now, since we made our toothpaste with blue, I think we're going to use maybe green this time.
Sure.
So put in about 10 drops.
10?
Yeah. Let's make it a pretty color green.
That's a lot.
And just squish some in there. There we go. Keep it going. All right, that's plenty. That was only 4 drops. Pretty green water, food coloring and water. Next thing we're going to do is add oil. You ever had salad where you have oil in your dressing and water and they don't want to mix? Well, the reason for that is called polar density. The molecules in oil are much farther apart than they are in water. And then that means oil will float on top of the water because it is less dense than the water. Go ahead and pour in.
About a tablespoon, maybe?
No, a lot. We just want to make sure we see a difference. You're going to see. Go ahead and pour it all in. There you go. You can see that they don't want to mix. It's kind of like when you have magnets. 2 magnets are the same. They don't want to connect. They kind of polarize themselves and pull apart. Well, it's the same thing with oil and water. They don't want to have anything to do with each other. The water molecules get along with the other water molecules, and the oil molecules get along with the oil molecules. Now, what we're going to show you here is what we're going to do is add some Alka-Seltzer. Any fizzy tablet would do. If you have a denture tablet or something like that, but I doubt that you do. Maybe your grandma does. And we're going to put this tablet in, and what it's going to do, it's going to make bubbles. Now, we're going to put it in here, and when it makes the bubbles, what's going to happen is that, here they come, is that the water molecules are carried up with the bubbles that are formed from the gas from mixing these Alka-Seltzer tablets. I'm going to put another couple in here so we get more fizzies. And here you go. Look at that. Look at how the bubbles come up and they carry the water molecules with them as they come up. This is your very own lava lamp. Let's just mix it up and see what we got. Whoa! Quite the big explosion of bubbles coming up. Those are carbon dioxide bubbles caused from this Alka-Seltzer, which, like I told you before, is a catalyst to this reaction. A catalyst is something that makes a reaction work better. It makes it work faster. So that's what we have. We have our very own lava lamp. You could always keep it around the house like this forevermore, and then if you wanted to start bubbling again, you just add another Alka-Seltzer or denture tablet and make sure, and that'll happen again. There we go. Shake her up, Ash. Thank you. Have a good day. Bye.